So who remembers how to graph lines? Nobody. I find that hard to believe. When graphing a line, what do we look for first in the equation? Josh? The y-intercept. So what's our y-intercept on this first equation? Okay, so I'm going to do my first equation in purple. I tend to do each equation in a different color just so I can more easily see things. So my y-intercept is 4. And then what do we do after we graph the y-intercept? Not the x-intercept. It's something with a -3. We could. There's a way that's already even easier than that. Josh?
Since it's -3, you go down 3.
Right, you do your slope. Down 3 over to +1. Down 3 over +1. And I usually do a few points just to get a better idea. So I just realized also that my line is very much not straight. But that's okay. And then connect the dots. There's your first graph.
I was supposed to make an announcement about the...
Can you come back in like 15 minutes?
Yeah.
Okay.
Thank you.
Okay, what about the next equation? What's our y-intercept there? -2. What's our slope? Oh, up 3 over +1, so 1, 2, 3 over 1. 1, 2, 3 over 1. And like I said, I usually do a couple of points, not just 2. And when we get to the parabola ones, you'll see why. You might want to do more than just 2 points on your line. All right, so where do these two graphs intersect? At 1, 1. So what's our solution? Anyone remember how we tell what the solution is? No one remembers how to tell the solution? You already said it. This point is your answer. Okay, so in a system, that point of intersection is your answer. Okay, if we were to do this algebraically, we would do substitution. So when we did substitution with lines, we got a letter by itself. So here we have y by itself actually in both of them. And then we substituted. So all of this here equals y. So I'm going to put that in for y in my other equation. So -3x plus 4 equals 3x minus 2. So in other words, I took what y equals and I plugged it in to where y is in the other equation. If I move my x's together, so subtract 3x, and move my constants together, we get -6x equals -6. Divide by -6, and we get x is equal to 1. Then we took that x value that we got here, and we picked one of the two equations and plugged it in for x. So if I choose the second equation, y is equal to 3 times 1 minus 2. 3 minus 2 is 1, so y equals 1. So what did I get for my x and y? 1, 1, which is the same thing we got by the graph. And it should match up if you did it correctly. Okay, so that's what you did last year. You did graphing and you did by substitution. Is it ringing a bell at all? Now that we've done one? Okay. We're doing the same thing, except one of our graphs now is going to be a parabola and one of them will be a line. So if we look at our first one here, number 1, you can graph it using whichever method you want. Factored form, vertex form, standard form, as long as you get it graphed. So again, I'm going to do one of them in purple and one of them in green, just so that way we can see the color difference. So I'm going to start with the parabola. How do you want to graph the parabola? Do we want to do axis of symmetry and find the vertex, or do we want to try to convert it to factored form if we can? I don't think we can do factored form here. Or standard form, or vertex form. This is where it's up to you. Anyone have a preference? Okay, then I'm going to use standard form. So my axis of symmetry, what's my B term in that parabola? Not 1. 0, because that middle term is missing. So in our quadratics, it goes ax squared b times x plus c. So our x term is missing. So we're going to have negative b over 2a. Well, when we have 0 on top, what does that equal? 0. So this x value is 0. What's the y value of my vertex? So we plug 0 in and get 1. So my vertex is 0, 1. So now we want to get a couple more points on our graph. So how can we try doing that? You could just pick a point to the right or the left like we did with vertex form graphing. So if we plug 1 in for x, what do we get? So
3.
We get 3. So 1, 3, and then I can reflect that. What do we get if we put 2 in? So 2 squared is 4. 4 times 2 is 8. 8 plus 1 is 9. That's going to go way up off my graph here. And then you can reflect it over. So I would strongly urge that you guys do as many points as fit on your graph. Okay, then we're going to do the line. So how do we graph this line? What's the y-intercept? The y-intercept is what? 5. So 1, 2, 3, 4, 5. And what's my slope? Down 2 over 1. We can also go up 2 over 1, up 2 over 1 to get your line. So you again want to do multiple points because usually your line is going to intersect twice on a parabola. So if we went from our y-intercept up 2 over 1 and then up 2 again over 1, we end up hitting that other point on the parabola. And so that's one of the reasons we like to put as many points as fit on our graph so that we don't accidentally miss a potential crossing point. Same thing with the line. We want to do more than just 2 points so we can get some exact points on our line. So where does it cross?
1, 3.
1, 3. negative 2, 9. So when we go to do this algebraically, and I realize I did not really leave myself enough room here between the first one and the second one. We're going to go about it the same way. Are both of these equal to y? Yeah. So that means I can take this 2x plus 1 and substitute it in for y in the second equation. So we're going to have 2x plus 1, 2x squared plus 1 equals negative 2x plus 5. This is where you get to choose your method of solving. So I'm going to move everything over to one side so I can figure out what's the best one to try. So I'm going to add my 2x and subtract 5 to both sides. So we get 2x squared plus 2x minus 4 equals 0. Want to try factoring? I think that's a good idea. So 2, I'm going to factor out a 2. And we'll have x plus 2, x minus 1. So what does x equal? 1 and negative 2. So does that already match the x's that we got in our picture? 1 and negative 2? Yeah, those are the two x values of our points. That means we're confirming we're on the right track. So what we have to do for the y values is we have to find the y value that goes with each one. So we're getting two answers here. Now, which equation do you think is easier to plug into? The parabola or the line? The line. So pick the easier one. Don't make yourself do the parabola if you don't want to do the parabola. So we'll have y equals negative 2 times 1 plus 5. So negative 2 plus 5 is 3. So we'll have 1 comma 3. That matches. And then for our second one, we'll have negative 2 times negative 2 plus 5. So that's 4 plus 5, which is 9. So negative 2, 9 is our second one. And that's confirming those 2 points you found graphically. Okay, how are we doing so far? Just so you know, on your homework, you're not doing both methods all the time. You're only doing both on like the front side. The back side, you're just doing algebraic. Yeah. So that's what I was checking right now is actually. So yeah, if you look at worksheet 7, that's what you're going to work on. You're going to have 4 on the front that have you do both just to verify. But the whole backside is just algebraic, so you don't need to do the graphing on the back. Okay, we're going to do one more where we do both, and then one that's just algebraic. What's wrong? Yes.
Could you explain how you got from 2x plus 1 equals negative 2x plus 5 to 2x squared plus 2x minus 1?
I just moved these over, so I added 2x and minus the 5 over, so that these added up to 0. And then over here I have 2x squared. There was no other x's, so I have my plus 2x. And these are like terms, so I add them together to get negative 4.
Wait, how did you do it?
What's 1 minus 5?
Negative 4.
Okay.
Oh, why don't you just do 2x and x for the factor?
You could have. You could have, if you didn't take out the GCF first, you mean?
Yeah.
You could have. Taking out the GCF just makes your numbers smaller and easier. Because if you left the 2 in there, then you'd have to add and then divide.
Okay.
And this is a lot easier to just be able to go, it's the opposite of each one if there's ones in front. So it should give you the same answers, whether you take out that GCF or not. Okay. Last one where we're going to do both together. The last one we're just going to solve algebraically. Okay. Which one do you want to graph first? F or G? G. Okay, so we go 1. So up 1, and then our slope is down 2 over 1. And again, I'm going to do this a couple of times in both directions. So if you remember from last year, if you were to go positive 2 and negative 1, you'd get the same line. So if I go up 2 but then negative 1, you continue your line in the other direction. And so I'm going to put enough points so that I have it covering my whole graph. And again, because this is a hand-drawn graph, it's not perfect, but it's close. That's way off. Let's try that again. So your graphs are going to be nice and perfect, so they'll come out nicer. This one, because I'm hand drawing them, they're slightly off. Okay, so now the parabola. So how do we want to graph this? Do we want to try factoring and graphing it in factored form, or just go with the standard form, axis of symmetry, vertex? I don't know if it does factor, actually, now that I think about it. 5 and 1, I don't know if we can get 2.
Can't you do like squares?
Do what?
I don't know.
Usually, I'm just going to do this. So negative b over 2a gives us negative 1. And so then our y value would be negative 1 squared plus 2 times negative 1 plus 5. So 1 minus 2 plus 5. That would be 4. So negative 1, 1, 2, 3, 4. There's our vertex. Do we know what our y-intercept is? Oops, I went too high. 0, 5. So I know this is a point, and then I can reflect it over. That's another one. So what do we get if we plug in 1?
Wait, what? No, wait, how'd you get the other points after you found?
This one, I reflected it.
How'd you get that one? Oh.
The y-intercept, right here.
Alright.
And then when we reflected it, we got that one. So then I'm going to look to see what do I get for 1 to see if I get another point over here. So if I plug in 1 for x, 2 times 1 and 5, we get 1 plus 2 plus 5. So that's 8. So that means it would be... So does it look like these are going to touch again? Not really. Because this is going to keep growing further away this way, and this is going to keep growing upward. So in this one, we only ended up with one solution, which can also sometimes happen. And that one solution was at 2, 5.
Negative 2, 5.
Negative 2, 5, thank you for that. So when we go to do it algebraically, we should confirm that answer. So we're going to take F and G both stand for Y. So that means I'm going to find out where this equals G. So x squared plus 2x plus 5 equals negative 2x plus 1. and we're going to solve for x. We can use whatever method we want. Factor, complete the square, quadratic formula, or square roots. So I'm going to move everything to one side to see which one I want to do. So I'm just moving over so I can get a 0 on one side. And I get x squared plus 4x plus 4 on the other. So can we factor this? Do we want
Yeah.
to complete the square?
Factor.
How does it factor?
X plus 2, x plus 2.
X plus 2, x plus 2. So what does x equal?
Negative 2.
And we only got the one answer, so that confirms we only should have one intersection point. So then we go back, and again, usually I choose the line because it's the easier equation to plug into. Negative 2 times negative 2 plus 1. So 4 plus 1 is 5. So that confirms that our ordered pair is negative 2, 5. Okay, any questions about how to do either graphing and telling or algebraic at this point? Again, you only have to do both of these on the first 4 problems. After that, you're just doing algebraically like we're going to do in number 3. Okay, so the number 3, we're going to just do algebraic. So we're only going to do what we did over here on the right. So you're going to start by setting the two equations equal to one another. So x squared minus x minus 2 equals negative x plus 2. So we set f and g equal to one another. Move everything to one side so that you get a 0 on one side and your polynomial on the other. And in this case, it canceled out our x, and we're left with just x squared minus 4. So what method do we want to use to solve x squared minus 4 equals 0? Factor, complete the square roots, okay. So square roots means we're going to add the 4 over, and then we're going to square root both sides. And we can't forget the plus minus, so the square root of 4 is 2. So that means we have x equaling positive 2 and negative 2. So that means we have to find 2 ordered pairs. That first ordered pair, again, use the line. Y equals negative, and then we plug in positive 2 plus 2. So negative 2 plus 2 is 0. So we're going to have positive 2 comma 0, that's 1 point. And then we plug in negative 2 for x, and we get 2 plus 2, which is 4. So negative 2 comma 4 is your other point. And those would be your 2 answers, or the 2 ordered pairs that your graph would cross at. This is what you're doing on the back, is just the algebraic. Any questions on any of it? This is our last topic of the unit. Okay.